Alright, welcome back again. We're still going to be talking about inequalities, and don't worry, I'll move out of the frame so that you can pause it and get your vocab down, because there is a few vocab words here that we're going to talk about as well. Today we're going to look at graphing inequalities on a line. We're also going to look at making them true statements, which is what this vocab has to do with. So there's a few things that we're going to talk about that you need to know for this. The first vocab word is a replacement set. A replacement set is just a given set of values that we want you to plug into an inequality to see if it makes a true statement. And we'll do a couple of those so you get the idea, you can see what I mean by that. The solution set would be after you plug those numbers in, which ones do make it a true statement. We're going to put that in the solution set because those are solutions, meaning they work to make it a true statement. The last one here is an empty set. An empty set just means all of the numbers I've given you to use as replacement values or to test in this inequality don't work. So you can wind up with a blank, or what we call an empty set with nothing in it. Nothing in it works. Just slide out of the frame. You can pause it if you need to get down your vocab. Alright, so looking at our replacement sets. So the first thing I do is I give you an inequality. Here our inequality is y is less than 25. So basically I'm asking you what values when I plug them in make that a true statement. So that means that this side needs to be smaller than 25. So if you look at your replacement set, we've got 24, 25, 26. When you see these three little dots, it basically means it's going on infinitely beyond. So anything larger than 26 is also included in there. That's what those three dots mean. Don't stop at 26. If there's no dots, it means it just contains those numbers. These dots mean it continues going in that direction. So basically all you're doing is taking each number and sticking it in to see if it works. So for example, I just take this, y is less than 25. First number I'm going to put in is 24. 24 is less than 25. Is this a true statement? Yes, 24 is indeed one less than 25. So we're just going to keep basically erasing this number and plugging our other number in. So now look at 25. Is 25 less than 25? No, it's the same. And you'll notice this doesn't say less than or equal to. That's why 25 is not in my solution set. It's not going to work. 26 is also greater than, and obviously here's where you can stop. We don't need to keep plugging them in. You know that after you hit 25, they're all going to be bigger than 25. So this, when you're set up this way, this is a little more self-explanatory. This is a little bit easier. So we're going to move on to this next one here. So I'm saying x is greater than 8. So I only want values for x that are greater than 8. So we'll start with 0. If I plug 0 in, is 0 greater than 8? No, that is not a true statement. That's a false statement. So it's not going to be included in my answer set. 1 is not greater than 8. And these ones are pretty straightforward. You probably don't need to keep plugging them in. You already know what's the first number that's greater than 8. The first number that's greater than 8 is 9. Why am I including 9? Well, because these dots here tell me that I need to keep going on and on and on and on. So actually what I'm going to do in my answer set is I'm going to add those dots in as well. 9 is the first number that's greater than 8. All the subsequent numbers beyond 9 are also going to be greater than 8. Obviously, I don't expect you to keep writing down numbers because you would never hit an end. You'd be writing till you died, and nobody wants to do that. So you can keep, if you get confused, you can just keep writing it and testing each one. Is 3 greater than 8? No. Is 4 greater than 8? No. But like I said, these ones are pretty straightforward. And just pay attention. The big thing you need to pay attention to here, there's no is equal to sign here. Down here, I have is equal to. So that means that there's another number I can probably include in my solution set. Alright, so over here I'm looking for values that are less than or equal to 8. So my first number is 4. If I plug 4 in, is 4 less than or equal to 8? Yes, that's a true statement. 4 is included in my replacement set. Let's try our next number. How about 5? Is 5 less than or equal to 8? Yes, it is. That's a true statement. It's going to go into my solution set. And you're just going to keep going that way. We don't need to keep plugging them in. Obviously, we know all numbers before 8 are smaller than 8. However, what you'll notice is this keeps going. There's one more number that's going to fit in my solution set. Why? If I plug 8 into here, 8 is not less than, but this says less than or equal to. 8 is equal to 8, which means it's also included in my solution set. All right, so you really need to pay attention to the if it's greater than or equal to, less than or equal to, or just greater than or equal to. All right, our final one here, I have t is less than or equal to 10. And the thing you'll notice about this is the dots are going this way, so that means all the numbers smaller than 10 are also included, including negatives, and we can continue infinitely going that way as well. So I want numbers that are less than or equal to 10. So what we could do is we can plug each number in, or we can just think about this logically. Well, what is the first number that would work for t? Well, 10 is less than or equal to, actually equal to, 10. All these other numbers would also be, so that means my solution set is actually going to look the exact same as my replacement set. All of these numbers can get plugged in to make this a true statement. So that's all we're doing, plugging it in, which ones work, which ones don't. All right, I have one more vocab term for you here, and it sounds a little confusing. It's a little bit like an oxymoron. Equivalent inequalities. Sounds strange because we're talking about inequalities, which means two numbers are not equal. But equivalent inequalities simply mean I have two inequalities that are stating the same thing. So, for example, I can write x is greater than 5, or 5 is less than x. Well, these are written two different ways. These are equivalent inequalities. They mean the same thing. I could also write x is greater than 8 minus 3. This is also equivalent because if I subtract 8 minus 3, I get x is greater than 5. Same thing I have written here. So that's what we would call equivalent inequalities. Now what we're going to do is we're going to graph inequalities on number lines. So I'm going to, I'll go over this, but first let me just briefly slide this out of the way. Before, when we just had whole numbers, if we wanted to plot whole numbers on a number line, there's an exact spot that they went. If I asked to locate 2 on the number line, you could just put a dot right here. There's number 2, I can find it on the number line. The only difference is when we're graphing inequalities, I'm saying it could be this number or it could be higher. So after we draw our dot, we're just going to draw arrows basically telling us that all these numbers would be included in our answer. The thing to remember about making our dots though, we have an open circle or a closed circle. This is because we have different signs. We have greater than or less than. That means that it's not equal to that number. So we're going to use an open circle because the open circle means that the number that I've circled is not included in my answer set. The closed circle we would use with less than or equal to and greater than or equal to because it means that the number that this dot is on, this closed circle is on, is included in our answer set. All right? And we're going to do some examples to help you out with that. And don't forget to pause it if you need to get your vocab. All right, so here I have number lines. I haven't put the numbers on them yet, but that's because I'm going to wait and see what my numbers up here are. So x is greater than 4. That means I'm going to have to put a 4 on here. 4 is an important number. Then if you want, we can fill in a couple of numbers around it as well. X is greater than 4. It doesn't say greater than or equal to, so 4 is not part of my solution set. 4 will not make this a true statement. So I'm going to use an open circle when I mark 4 on my number line because 4 does not make this a true statement. I want to show you where the numbers are that will make this a true statement. So I want numbers bigger than 4. So which way are the numbers that are bigger than 4? This way. And what you'll notice is if your variable is on the left, the way that your greater than or less than symbol is going is the way your arrow should point. This sign and this sign look the same. That only works if your variable is on the left. Over here where my variable is on the right, it's going to be pointing in the opposite direction. So don't get confused by that. And if you want to use that trick, you're always welcome to. We can rewrite this way. These are the same thing. 9 is less than or equal to x is the same as x is greater than or equal to 9. All right? I'm going to erase that. I don't want to confuse anyone. But yes, so keep that in mind. You can flip the order as long as the sign flips along with it. So over here, this is always the number that I'm going to mark on my line. I need a 9, and then I'm just going to fill in a couple of numbers around it. Here you'll notice I have a less than or equal to sign. So that means I'm using a closed circle because 9 is equal to 9. So that would make this a true statement. I want that 9 in there. Then I'm looking for, and I'm going to read this backwards. I always look at the variable first. X is greater than 9. So I want numbers that are bigger than 9. So I'm going to go this way. All right, down here, 0, so that's the number I'm going to want to mark. I just like to put a couple numbers next to it as well. I have a less than or equal to. Once I see that equal to, I know it's going to be a closed circle because 0 is equal to 0, so that'll work. Now my variable is on the left, so that means this shows me the way that my arrow will point. It's going this way. Or if you just think about it, x is less than 0. Well, where are the numbers that are less than 0? They're the negative ones. So my arrow is going to go that way. Again, over here, 2 is the number I'm going to wind up marking. I do not have an equal to here. This is just a greater than sign. So it's going to be an open circle because 2 is not greater than or less than, 2 is not less than 2. So keep that in mind. My variable is on the right, so my arrow is pointing in the opposite direction of this. So x is less than 2. Where are my values that are smaller than 2? Over this way. So really all we're doing is we're taking our phrase here, our mathematical phrase, we're graphing it onto a number line to help us see where the values are that make this a true statement. It's another way for us to kind of graph these solution sets instead of having to write out all the numbers. Again, if you're at all confused, rewatch the video. You can type your questions into the comments. You can email me. You can ask in class. All right? Have a great night.